see our last question there. A, B, C, D is a parallelogram. B, D, A, B, C, D is a parallelogram. So we've got A, B, C, D. It's a parallelogram. Now, if it's a parallelogram, we can now safely put this. I like doing this. Why? Because we are given that. We are given that. We are given that. So why not what call putting it up also? Now, what can we say also is that BD is equal to, and AC, BD and AC, BD and AC intersects at O, okay? AF is equals to OD, okay? Then CO is equals to FB, CO is equals to FB, okay? DA and BF, DA and BF, they are produced to meet at E. So, okay, no problem about that. Now, prove that BOAF is a parallelogram. That's what we need to know. So here, we want to prove that BO, so BOAF, it is a parallelogram. What are we going to do now? We know we're going to say, okay, in this case, we're going to say our BO will be equals to OD. BO is equals to OD. Why? Diagonals of parallelogram bisect. We are looking at this is a parallelogram here, but we are finding BO. Now let's also see AO is also equals to, before we continue, therefore, so here we see that FA, therefore FA is equals to BO. Why? We have proved that. Okay. Then the next one here is our AO. AO is equals to OC, because we're looking at this parallelogram that we are given already. So in that case here, diagonals of parallelogram bisect. Now, when we have that, so we can now conclude to say, therefore, AO will be equals to FB. We have proved that. Now, when we have that, so now what are we going to be seeing? That is that we are now seeing this. That's what we are seeing. So when we have that, we are now going to say, okay, A. So if these two are equal, then we are now saying FBOAF is a parallelogram. Let me just use the shortcut here. It's a parallelogram. Why are we saying that it's a parallelogram? Because opposite sides of parallelogram are equal. That's what we have there. So opposite sides here, we have proved that opposite sides are equal. Then we can now safely say this is a parallelogram. Now let's go on to 8.2. Prove that AD is equals to EA. AD is equals to EA. Okay. Now, if I prove that AD is equals to EA, we need to check here first, okay, that, okay, now, if we had to look at this, we have got AD, we also have BC there. So we can now link this BC with what you call EA, but how are we going to do that? That's the question. So I'm going to add something here so that you can see nicely here. Now, why am I adding that? I want to show you guys that these are all parallel. So here we are going to say, okay, what is it that we can do now? We can now find that we can now say what you call EA is parallel to your BC. Why are we saying that it's parallel to BC? It's given. It's given that this is a parallelogram, and if it's a parallelogram, AD will be parallel to BC. So that's what we are given here. So it means that your AD will parallel to BC, and this is a collinear. It's just the same line that we're dealing with here. Now we are going now to say, okay, what about the other side? AO, we find that AO is parallel to AO is parallel to BF. Okay, so in that case here, why are we saying that? Proved. So we have proved that this is a parallelogram. So it means that this side here is parallel to that side. Okay, so that will make the whole side parallel here. So when here is parallel and here is parallel, it also means it continues like that, okay, because it's in the same line. That's what we are saying here. Now, the other thing is that what we can also, once we have that, we can now safely say E, we can now say B, C, A, E is a parallelogram. And the reason being opposite sides are parallel. Opposite sides of a parallelogram are parallel. That's what we know. So opposite of the parallelogram are parallel. Now, in that case, once we say that these opposites are parallel, now we know that EA is equal to BC. Now, when we have EA is equal to BC, your EA, that means also it's equals to AD. Because what is it? This is a parallelogram as well. Okay, so here prove that EA is equals to AD. So we have proved that. So you can get your 4 marks from there, then you'll be fine. Okay, so guys, I think we now understand what you need to do when you are dealing with parallelograms, knowing the properties and remember them all. There are not many. You can just practice with your with your pen. Just just complete everything there. Just make sure that your opposite angles are equal. Just make sure that your opposite sides are also equal. Then also make sure that your diagonals are bisecting each other. Then you also have to also prove that if one pair of opposite sides are are equal and parallel, then the shape is a parallelogram. So those are the things that you must actually be remembering. Okay, that's what you need to understand. So when now you're putting your information together, there is no order to it. Yes, there is order though, but we are saying figure it out. You maybe write on a paper, your things, write on a paper, whatever comes to your mind. Okay, if it's a parallelogram, put your arrows first. So indicated by the arrows first. So if you're told that it's a parallelogram, put your arrows. When you put your arrows, it's going to help you. And again, another thing that you can also do is that show that these sides are then equal. So show that these sides are then equal. Yeah, opposite sides are then equal, because we have got, we have got, we are told that it's a a parallelogram. Okay, so that's what you need to understand there. That's what you need to understand. I'm just going to circulate because we just added it now. Okay, so that's what you need to understand, guys. When you add that information, it's going to help you now to figure out some of the hidden things that in your diagram. So whatever you're given as a parallelogram, label it. then you discover what you call good things there. Okay, until next time, guys, all the best.